Hello students, now we'll start Mathematical Tools lecture 4 which is Differential Calculus. Here you see, first we'll explain about the physical quantity. What is physical quantity? What about the matter in the universe can be expressed in terms of one numerical value along with this unit is the physical quantity. Okay, it can be expressed in U. N is the numerical terms. Now, these physical quantity can be divided into two types. One is the constant and another is the variable. Constant, you see the value which is always same. All time it is same, 5. It is constant. 6, it is constant. And variables it will be vary. And here it is two types. One is the dependent variable, another is the independent variable. Here you see we are explaining with example. Here is the equation y equal to x plus 7. Now here you see when we plot a graph, what we are taking? We are taking the value of x 0. You substitute the value of 0 and get the value of y 7. Get the value of again x 2, sub 2 and then 9 and so on. And accordingly we plot the graph. Here you see we are considering the value of x is first, then we are getting the value of y. Here x is the independent variable and y is the dependent variable. Whatever the graph we will plot, we consider the independent variable in x direction and dependent variable in the y direction. Okay. Now we move to the function. What is function? Function is a real relation between two variables. One is the independent variable and another is the dependent variable. And it can be written this way: y equal to fx. Here, when you are considering the value of x and find the value of y. And this type of function is four type. One is the polynomial. Here you see value of x is 2 power and plus 3x. Trigonometric function is the y equal to fx equal to sin x, that means y, and exponential function fx equal to e to the power x, and logarithm function fx equal to log x. And if you go to the derivative always taken with respect to of the variation of the dependent variable with respect to independent variable. Here derivative can be written as dy by dx. Here it is nothing but the rate of change of y with respect to x. And it is also another form is that is the slope of curve. And in case of physics, we find the instantaneous velocity, instantaneous acceleration. Okay? That is the rate of change of this. This one is the independent variable with the dependent variable. Okay. So in mathematical definition, you see we have considered y equal to fx. Okay. Now here, what is the y plus delta y? You substitute the value of in place of x plus delta x. That means when y changes delta y and x will be changed to delta x. Delta x change, then y will be changed to this x plus delta x equal to y plus delta. So what is the actual change? Change delta y equal to, you see delta y equal to f of x plus delta x minus y. So that equal minus all fx. So rate of change equal to delta y by delta x equal to fx plus delta x minus fx divided by delta x. Now if this del x variation tends to 0, not 0, tends to 0, then it will be dy by dx equal to fx plus h. It will be del x. So now move to the formula, different formula. If we go to the x to the power n, then dx of x to the power n equal to n x to the power n minus 1. And if any constant is there, it will be, there will be no derivative. And derivative of any constant dy by dx, any constant equal to 0. Okay. Now move to one example. Here you see, if we consider x equal to 3x to the power 1 by 2 root x, then find dy dx. Dy dx equal to, just you put in place of y, it is y, in place of y 3x to the power 2, so it will be 3 will be from x into 2 x to the power n minus 1 into 2 minus 1, so answer will be this one. And next we move to three type of formula given: sum, difference and chain. Sum formula, here you see this is the function sum of two functions, then derivative will be just like this. If d dx equal to d dx of fx plus gx equal to f dash x plus g dash x. Similarly, for difference, plus will be minus. And in chain formula, first you see different of all this, f dash of gx full function is there, then again what is the function, another function, that will be, if it is another function it will be so on. And I am explaining one example. If y equal to 5x to the power 4 plus 3x to the power 3 by 2 plus 6x, then find dy dx. We are getting dy dx, substitute the value of y in place of the here d dx of this one. So here you see applying the formula, chain formula, we divided these three parts, then 5 constant comes out and x to the power 4. So x to the power 4 means 4 into x to the power 4 minus 1 equal to 3, and so on. So this is the final result. And product formula, here we are getting product of two functions fx and gx. So what will the formula? That formula is that one function is there, derivative of next function plus another function, derivative of the first function. So here we are considering one example: y equal to x cube plus 1 into 2x to the power minus 3 plus 1. Find dy dx. Here this is first function, this is the second function. So here we are taking first function, second function, first function derivative of second function plus second function derivative into derivative of first function. And after taking the derivation, we are getting this result. And quotient formula, here you see it is the division of two functions, fx by gx. Here gx square into gx f dash x minus fx gx. We are taking one example: y equal to x square plus 1 divided by x minus 2 dy dx. This is the fx and this is gx. So if we put here instead of y, you are putting this value, and here you see gx square gx into f dash x and fx g dash x. After differentiate this one, here you see x minus 2x, derivative of 1 equal to 0, x square plus 1, derivative of x minus 2 is that equal to 1. So this is the final result. Logarithm formula, if we take the logarithm formula, here d dx of x to this x base e equal to 1 by x, and d dx of x to the base a, that equal to 1 by x log a to the base e, and e to the power x derivative equal to e to the power x, e to the power ax. Here you go to the chain formula, e to the power x derivative is e to the power x and ax derivative is a. So this is the logarithmic formula. And trigonometric formula, d dx of sin x will be cos x, d dx of cos x equal to minus sin x, tan x sec square x, it is cot x minus cosec square x, sec x tan x, and cosec x minus cosec x cot x. Here you see one, for remembering that one, sin x is cos x, cos sin, tan will be sec square, cot will be cosec square, sec cosec tan x. One thing is that what are the value of what function is starting with c. You see, in every case derivative is negative, otherwise it is positive. You can remember this way. Now we go to the application. One application, velocity. In physics we have to find out the velocity. Suppose distance is x, we know that velocity is the nothing but rate of change of velocity with displacement with time. This is time. So v equal to ds dt. Now you will find the value of s equal to 4t square, v equal to ds dt, find that 4 constant and 2 will be there 2t, it is 8t. Similarly, if we find the value of acceleration is also dv dt, a equal to dv dt, and if v equal to 8t, and then what will the value? Value will be dv a equal to dv by dt v. So you write here dt of v is 8t, so 8 and d dt equal to 1, so it will be 8. And one example is there. Suppose s is represent this term 27t plus 4.9t square meter. Then find the value of initial velocity, acceleration, final velocity at t equal to 0, t equal to 3 seconds. Velocity equal to rate of change of time dv dt, and here you can write this one. So 27 and here 24 and 2t derivative equal to 2 into t. When t equal to 0, then it will be 27. You see initial velocity means t equal to 0, and when t equal to 3, v equal to, you see, substitute the value of 3, 27, 4.9 into 2 into 3, that result is this one, and acceleration that equal to dv dt. dv dt means here you substitute this one 27 and derivative. So this is the total whatever the required in the physics or the derivative I have given here. Thank you.